Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, yeah, my name is Javor. I'm Program Manager on the Windows Azure team. So that's on the Windows Azure Mobile Services team, and that's the team that delivers a backend as a service solution for mobile apps built using Windows, Windows Phone, even iOS, Android, even all those platforms. I think I'm on, yeah.
Now you're on.
Okay, great. Can you guys hear me?
Yes.
Okay, so I work on the Azure Mobile Services team. We let you create an easy backend for your Windows 8, Windows Phone app, also iOS and Android. How many of you have heard about mobile services before? Oh, okay. How many of you have actually played with mobile services? Okay, so my demo is going to be interesting to at least half of you. The rest of you can. There's pizza in the back, and then Jeff's gonna come in after me. So Jeff wrote Fourth and Mare. You've probably heard of him. And so I'm going to show you how to get started building an app in a very easy, straightforward, turnkey sort of way. Jeff's app is not that turnkey. Jeff's app is pretty involved and rather complex. So he'll show you how to go from like a simple app to like actually a really advanced full production app. So mobile service is a great way to get started. When you grow up to a full app, you might have slightly different needs, and Jeff's going to talk about that. So I already talked about this, but basically we provide you an easy way to add a backend in minutes. So if you're a client developer, if you're not used to writing Azure code, you're not used to writing server code, mobile services is for you. We try to make adding a backend extremely easy. If you look at if you can compare these two pictures, right? So you can follow the directions and kind of end up with a nice, easy product. Kind of put the Legos together, do exactly what they tell you. That's kind of mobile services for you, right? It's very straightforward. It's very step-by-step and turnkey. It's very productive. Not necessarily as flexible. If you're Jeff, you'd go and build something like that. Basically, you'd be like, oh, screw the manual. I'm going to go and put all these pieces of Azure together, and different cloud providers actually put them together and arrive at something flexible, tailored to my needs, right? So first we're going to talk about this, and then we're going to talk about that. So what do you get from your mobile services backend? What are the things that we provide for you? I already mentioned we provide a backend, so that's basically a SQL database for you with tables for the entities you'd like to store. We support a variety of clients. Like I mentioned, we just today released to production our HTML client. And by the time this recording is live, the HTML client will also be in production, so I'm allowed to talk about that. So you can now target websites and also PhoneGap. So you can actually do, you can do either native development across all these platforms. You can even do PhoneGap, or you can even embed your code as part of a website, all using the same backend. Yep?
The concept.
Okay, great. And the key thing is we share the same backend across all these services. So you only write the backend once, which is a good thing. We allow authentication and authorization to be done very easily using a set of support auth providers. We support all the major ones, Microsoft account, Facebook, Twitter, and Google. So you can go ahead and configure your app very easily and then authenticate your users, and we manage their identity on the server. It's very easy to do authorization against their identity. So that's a common problem we've gone out to solve. Go ahead.
And you can also do custom.
Right. So you can also do custom auth. There's a blog post by Josh Twist from our team, so you can even do your own auth if you'd like. We also make push notifications really easy. So if you've read a lot of the documentation for push notifications, they'll spend like 15 pages talking about, okay, here's different tile templates, it's so pretty, but they never talk about, and then there's that REST API doc, and you have to figure out yourself how to write a client, wrap it in a .NET service or something, host it on Azure. You have to do all those steps to actually send the notifications to the app. Displaying them is the easy part. Actually sending them, that's the hard part. So that's the thing we make really easy, and I'll show that in a little bit. Oops. Then we also support scheduled tasks. So if you want to run a task against your backend, every 15 minutes to clean up some data or to pull Twitter and pull some information, we let you do that. We also integrate with the store, right? So if you'd like to use pusher, for example, for WebSocket connectivity, you can do that. You don't have to do anything weird. Just go and add them as part of the Azure store. And I've been authorized by VPs high above me to give you 10 for free for each of you today. Isn't that super exciting? You're not excited because you know that they are free. 10 are free for everyone. So you can get started with 10 for free. Then you can start buying reserved ones if your app grows really large. Back there.
I was saying, can we expand our services once we get popular?
Yeah, exactly. So you can. So the 10 are shared hosting, right? So they're going to take a little bit of time to warm up when and you might get evicted sooner because there's other tenants of that machine, but they're free. Now, if you really want if you want to stay always hot and you want to have the whole VM to yourself in case you're doing crazy computation in the back end, you can flip a switch in the portal and get a reserved VM for you, and of course then you have to pay.
So we really pay just for the storage used.
Yeah. So the mobile service itself is free. You're going to need to associate it with a SQL backend, and you have to pay for SQL. If you're Microsoft employees, your MSDN subscription, or if you have an MSDN subscription, it's going to cover, well more than 10 sites. I'm running a bunch of them, and I haven't gotten a bill yet. So.
I think you also pay for the bandwidth, right? After a certain point of time.
In the free mode, you're going to get capped. In the free mode, you're not going to pay anything. You're going to get capped.
Yeah, so effectively it's the same thing. I mean, you pay, you get.
Yeah, if you want to get, yeah. So at some point, if you it's the same. I have to go check what the exact cap is. But yeah, we're not going to start charging a credit card unless you explicitly flip that toggle. We can start charging you then. So the good thing about mobile services is we've made it super easy, and we have a great dev center with a lot of content that I've written a lot of it, and we have a team of writers writing a lot of it as well. And we cover a lot of the main scenarios with nice tutorials with lots of screenshots. We've been heavily inspired by Scott Guthrie's blog. If you notice how he does, and he puts like red, things around his screenshots, like step by step, very clear. So great tutorials. Also, our SDK is on GitHub. Actually, everything, even iOS and Android, it's all in our GitHub repository. So you can go ahead and read the code. You can file bugs in the issue tracker. You'll notice we have only 4 bugs when I took that screenshot. So let's get that count up. You guys can go file your own bugs. And the best part is you can actually fix the bugs yourself. So if you find something that's really annoying you, you can actually fork our repository, send us a pull request. We're going to review it. And if you didn't try to check in garbage, we'll probably merge it in. So you can very easily actually fix the bugs you find, which is great. It's not the .NET framework. You can go and fix stuff if you find it. So that's pretty much all of my slides today. I'll do a little demo, and I've written a game, and so the games is something we're seeing quite a few people actually write with mobile services. Even though we like to think of our sweet spot as say something like a to-do list application. I mean, sort of something that needs a backend, necessarily not a game, not real time, not a shooter or something like that. But maybe like a leaderboard to your game. In this case, I'm powering my entire game off of mobile services. So let's go ahead and try it out here. So, for example, do you have your phone? All right, so Jeff and I started a game earlier. Which game is that?
Game 6.
Game 6, all right. So let's see if I'm in game 6. All right, so now let's see if it's my move. Okay, it was my move. Now, go ahead and try and make it move in the phone version of the app. I should get a push notification. There you go. It's my turn, and I'm not very good at writing these apps, so you have to go and actually refresh to see Jeff's move. But there you go. Okay, so you made a move, and this is the way this works is that we're sharing the same backend, right? Both these are going against the same server data. So that's how this app works. So I'm showing you the Windows 8 version. We're going to switch over and look at how to actually build the phone version of this app. So. Go over to Visual Studio here, and so this is just a blank app. It has a bunch of hard-coded data in it. It doesn't actually connect to Azure at all. So you guys can see okay. The lights are okay. Cool. So the first thing is I'll go to the Azure Portal, and I've created a mobile service already, right? It's called Align 5. So basically, up here is where we give you kind of the getting started information. So if you want to add this backend to your Windows Phone 8 app, you go to the section here. We let you download our SDK, add it to your app. We give you sort of the connection string to your mobile service, which is this basically this line here with the URL and your access key for your application to talk to your backend. We'll let you create a table and just kind of get on your way. We have a very nice, easy quick start experience. I'm not going to follow this because you've probably seen the demo of the quick start a million times, but I'll go ahead and add this information to my app. So you'll notice if you go to the data tab here, I already have a games table and a players table, so you'll see me reference that as I build my application. So let's go back to the app. We'll go to the code behind here, and I'm going to add that first snippet, which basically defines my mobile service. So I have this config file here. I didn't want to, this is just to make my life easy because this is checked into a public repo. I didn't want to check in my secrets, but basically this one file here contains the secrets. I've just checked them in separately so I don't have to keep them as part of my source. So, all right, so I have this mobile service variable. Then the next thing we're going to do is we're going to go inside our main page here. And we're going to look for this authenticate method, and that's the first step we do in this game. That's the thing you didn't see, but Jeff and I are already both logged in, so we have to make sure the user, the first thing they do when it comes to the app, we got to get their identity. So we're going to ask them to log in. So I'll drag my authenticate method in here, and this is pretty much. I'm pretty much just taking advantage of the live SDK. So or it's called Live Connect SDK now. So this SDK basically lets you sign users in with their live ID on the phone. It basically pops up a little browser control and navigates over to live ID, lets them type in their credentials, and gets you back an authorization token. So this code I've essentially copy pasted from their SDK. So you notice I have this check registration method missing here. So once I've authenticated the user, I want to make sure that I've registered their push channel so I can send them push notifications. So that's what I'll do in that method. So I can go ahead and add that. Oh, I think before that, I actually have to go inside of this because I need to actually call the authenticate method. So I'll just put it in here. Oops, sorry. Sorry, I have to put it inside of onloaded, I think. Right here. Okay. And then the next thing is another change. Before I drag in check registration, we need to basically get the current user identity. So that one I currently hard-coded to this blank string, but I can actually get that from the live SDK. So I'll just paste that in here. So this is basically getting the user identity from within my SDK. Now we're going to do the check registration stuff to register the push channels. And do you guys know how do you? I'm going to make this a little bit bigger so you can see. Was it? I can just minimize this thing, I guess. Right, so you notice it starts with just a pretty simple a push channel registration code that's stolen off of the SDK for the phone SDK. The one thing you'll notice that I do differently here is once I go ahead and get the push channel, I actually add it to my player table. So this is how I'm actually going and storing the user's push channel up in the cloud, right? So that's basically a reference, my client-side reference to this server table here. And if you notice, Jeff and I have already played the game. So in here, you'll see, here's my Microsoft account user ID, here's Jeff's, and then here's our push channels. And in my case, I'm using WNS for my Windows app. Jeff has, and I also have a phone app as well, and Jeff just has phone just because he's logged in only on the phone. But as he logs in on more devices, we're going to update this user object for him here and store all his push channels so whenever we make a move in the game, we can deliver a notification to him. Okay, so now, yep, go ahead.
Are you identifying the device on the device itself, or are you identifying the server?
So currently we're identifying them well, what do you mean? So we have the user's identity if they're logged in. If they're not logged in, we don't have a notion of their identity.
Like application, how do you know which device the person is coming from? You have two separate columns, one for MPNS and one for...
Yeah, so I would have to, if they have multiple devices, this would break, right? If they have multiple phones, then it will break because I'll just keep overriding the push channel. So I have to be smart then. You're right. Like I have to basically start adding a list of push channels.
Determine whether they are coming from Windows 8 or phone. Like if you push it in your app.
Yeah, I always pushed it both.
Right.
How do you know what the client is? Is it a phone or is it a...
Is it the...
Well, because notice like I had to actually manually do this registration, right? Like this registration step, like I had to go here and manually set this property on my player, like MPNS channel, right? So in my WNS code, like in my Windows code, I'll actually set the WNS property. So I had to write custom code based on the platform. But you have to write custom code anyway because the push channel registration logic is different anyway on the different platforms. So yep, you have to know. And now you notice my table reference is missing, so I have to basically add my table reference. So here's the references to my two tables. Mobile services, that thing we instantiated off of the app object, so that's still there. That's how you get the references to your table. You say get table, and you give it the type you want to work with. Okay, so now let's look at the refresh method, wherever that is. Right, so currently the refresh method is kind of, it's pretty bare bones actually. You notice I'm just saying data context null for all my UI controls. They're not really doing much, right? They're just showing blank data. So let's add the implementation for refresh. Let's get rid of this. And so here's some interesting code, right? Here's me actually querying the server to get some data back. So in my UI, you noticed when I showed you the app, and I can switch over again real quick so you guys can see. I had two columns. I had open games and I had my games. And so these are different queries against that server table. The open games is basically games that don't have any players assigned to them yet. And my games are games where either player 1 or player 2 is my ID. So I have to write that logic on the client, right, to do the right query. So open games, basically you've noticed I'm just using link. I'm saying, okay, open games are games where player 2 is null, right? Because player 1 is always the guy who created a game. So you create a game, you always set player 1. Player 2 will be null if the game is waiting for another player. So I query these things, and you notice I'm using link, right? And that's one of the nice things about our C# SDK is we let you query your server using link on the client, which is nice and easy. Then the my games query is a little bit more advanced. So I'll say, where where either the players is null and then one of them is me, right? So that's what this query says. So that's how my games works. So where none of the players are null and one of the players is me. That's what this query says. It's a bit scary, but it's linked, so it was easy writing it, and it's hard to read it back. And then I use I set these two collections to my data context objects so they can pop up in the UI. One thing I remembered actually, so refresh, that should get called only after I'm authenticated and registered, right? So somewhere down here, it should call refresh. Or maybe, yeah. Yeah, so I'm just wondering if that's the right place for it. Because do we want to refresh before we're authenticated? I think I need to put that somewhere else. To move that out of there. Actually, let's keep it for now and see if it fails. Okay, so then how do you actually join a game? So I currently have just an empty button that does nothing. So join game on tap. So that's that button here in the UI that lets you join. So go ahead and drag the implementation here. So you notice like the way I join the game is actually I get the game table and I get a new a game object and I stuff it into the game table. And that's going to be interesting, right? Like how does updating something actually make me join the game? So that's just a little convention I came up with the server. So let's look at the mobile service backend, because obviously that doesn't make sense. If it was just a simple update, like it's it's not really doing anything. It's not even touching any properties on the object. So how does that even work? Well, we have this notion of server scripts, and that's something that you actually need when you're doing a game, right? You need to have all the logic encapsulated in a method on the server. You can't run your game loop in the client. So actually, you'll notice I have some smarts in a lot of these methods. I'm not going to cover this one, but let's go with this update method in my games table. Let's see what happened here. So you'll notice when I go ahead and insert a game, first it checks, okay, well, does this game exist already? And if it does, then I'll either join the game or I'll make a move. And that's really where my game loop lives, is inside this update method. So I'll send an updated instance of the game back to this update method, and depending on what it sees, it will know what to do. So if I sent it a game that doesn't have a player 2, it will call this join method, join game method here, and it'll set my user ID as player 2. So it'll register me for the game. If I send it a game and I'm already player 2 on that game, it'll call this make move method. And the make move method basically goes through a bunch of validations. It wants to make sure, okay, is it your turn, right? Because it may be the other player's turn. Are you trying to move in a column that doesn't exist, right? So I'm trying to place a move in, column 15. This only has 7 columns. So this is kind of it's a bunch of server validation that the code needs to live somewhere. So this is basically our way to let you encapsulate a little bit of server logic when you work with your data. So, any questions?
What engine are you using to run the job?
So this is actually running Node.js on the server. Yeah. So there's a little bit of disconnect for C# developers. A lot of the time you look at this and you'll be like, oh, I have to write JavaScript now. But I mean, if you think about the bigger picture, right? First, we're definitely looking at adding C# support. But if you look at the breadth of developers we're targeting, we're also targeting people that do iOS, Android, and HTML, right? So it's not just for C# developers; it's for a much bigger community. So we try to pick a language that makes sense across everyone. And so Node was pretty lightweight and pretty well received. So that's what we've used. All right, so going back to Visual Studio, we hooked up the logic to do join game on tapped, right? So that's when I go ahead and join a game. Now, how do I create a game? I'm going to replace this other handler. You notice I insert basically a blank game object into the game table. So I can go ahead and take a look at that. So let's look at the insert method. And it'll populate some of the properties. It'll populate my ID as player 1. It will create a new board. It'll create an empty new board. And you'll see basically that's how we represent the board on the server. So like all that logic has to be on the server side, right? So people can't cheat. So that's why I create my new empty game. Okay, and now the last thing is my make move method, which is when the user goes inside the actual grid of the game and taps one of the columns to try and make a move. So let's go inside this game board, code behind, and there should be a make move method. Maybe it's not there. Board moved. And I need my reference. Oops. Whoa. How did I do that? Okay. Okay, and this. Oh, actually, sorry, I'm pasting this in the wrong method. That's why it's not working. So I'm pasting it, instead of pasting it, I'm pasting it inside my game board class, which is just, it's a UI only class. I actually need to paste it inside my game page. Okay, now it makes a lot more sense. Here's my empty method. All right. Right. Oh, sorry. Oh, yeah, thank you. All right, great. So board moved. So this is when people actually tap a column. I'll get a reference to my game table the same way we did it before using our client. I will do some checks, right? Is the game in progress? Is it my turn? And these are constraints that are also enforced on the server as well, right? So, but this is just, so that instead of getting a weird response from the server, like a 500 error or something, they'll get a nice response within the game. Then I'll take the game object. I'll use this move property to indicate which column they try to move into, and then I'll basically call I'll call an update to insert the game into my table on the server. So that's all I had to do. I mean, it's it's a bit of code, but it's actually I have a full game working. So let's go ahead and just run it to convince you guys that it's the right thing. So go ahead and start it in the emulator. Okay. These should be here somewhere. Well, anyway, I have an easy way of cheating, actually, because this is in version control. Oops. Oh, wrong folder. This is always stressful when you're trying to fix your demo. Do you guys have any questions while I do this?
Oh, I think you see the results again.
It's gonna work, I promise. Jeff has it working on his phone. All right. So here's my app. So the first thing is we did build in authentication. So this is basically that call to authenticate using the live SDK coming up to ask me. And in this case, actually, I've already logged in because typing the password on the emulator actually reveals your password. So I've logged in beforehand. It's asking me to give the app some permissions. Nothing scary. So I say, OK, let's do that. And then the next screen should just basically present the same information I saw in the Windows 8 version of the app. So here's the open games. Here's my games. Here's the app. Here's the game I was playing against Jeff. I can go back. I can go ahead and start a new game. I can check in on that game. And you notice actually, like I have this interesting bug which I've kept for demo purposes. You notice the Windows 8 version of the game gave me a notification it's my turn because now it thinks I'm actually playing as two separate players, which is nice for demo purposes. So Win 8 just gave me a push notification saying, OK, it's your turn. I can go ahead and make a move. And it gives me a notification again. So it's very fun to play this with yourself. I also want to show you toast notifications on the phone. So if I actually go to the Windows 8 version of the app, and that's not what I wanted, I need to close the app because toasts only show up when the app is hidden. So I go to my Windows version of the app here. You find that. Let me actually bring it up again. So here's the game I was playing, And if I make a move, we should be able to see a toast going up in the phone. There you go. It's your turn. So I was able to deliver the push notifications both to the Windows 8 client and to the phone client. I want to spend a minute on, because I have 3 minutes left, I want to spend a minute on how I actually configured push notifications and how did I send them. So the first, so you know, you can't, for Windows 8, you can't just send unauthenticated push notifications. That's, you need to register on their developer portal. So on the push tab here, I had to go and add my client secret and my package SID. So that's how they authenticate the guy who's trying to push. For Windows Phone, actually, if you're under 500 notifications, you don't need to authenticate at all. You can send unauthenticated pushes to up to 500 unauthenticated pushes per device, I think. So I didn't need to do any auth for that. Let's find the script where we actually send those notifications. And that's going to be inside my games table here. It's going to be inside of update.
Quick question here.
Yep.
So, is there, okay, so do I have to do anything to set up authentication at all here, even for Windows Phone?
For Windows Phone, you don't have to do anything. For Windows 8, you had to go and configure those two things. You have to go to the Windows 8 dev portal.
So, I mean, that's like basically copy paste some stuff and put
Yeah,
here.
start paste some stuff, and then I'll show you the code you have to write. But
so after that, there is, okay, so then I guess there's no point doing an authenticated really, just copy paste.
yeah,
Okay.
yeah. That's the whole point. Is that this is your this takes the part of writing that relay yourself. Okay, so here's how I send push to WNS. I get the WNS channel, and that's the thing we sent on our client when our client registered. So I send a toast, to the Windows 8 app, and then for MPNS, I have a very similar API. I just give it the channel, and then I give it the text I wanted to push. So it's as easy as this to actually send the push notifications. Again, for Windows 8, I had to configure those two values. For MPNS, I didn't have to do anything at all. So with that, I'll take a quick pause and take any questions. Yeah, you go.
Hi. For someone like me who has never done any cloud thing and probably doesn't even understand most of the concepts necessary, where would I go to see a walkthrough or to start just the simplest thing?
Yep. Oh, sorry, can you repeat the question? If you've never done any cloud development, where do you go to get started? So this is our dev center, which I showed a slide of previously. I guess it didn't come up. Yeah, basically you'd go to our developer center, and then you can go ahead and pick mobile up here, or if you can memorize the URL, even better. You can start this tutorial, right? So you're a phone developer, you pick Windows Phone 8 here, and you say Start Tutorial. When you create your mobile service, there's a project there that you can, and that quick start page I showed you, there's a project that downloads a zip file. You run the zip file inside of VS, you get your starter app running. So there's one button to create a table, one button to create the starter app and download it. It's very easy, and you can and we show you how to do it in this tutorial as well. So very straightforward and easy. You have a question?
So if you've done, so I've done a bit of MVC database stuff, and I'm comparing this with how that works. And specifically, if you have associated data, so let's say you have, a game with multiple players, or an array of players. So the way you do it in MVC is you have a navigation property,
right? And
anytime, you have a list of players associated with the game object, and it would just take care of it. Is there any easy way to do this? It seems here you have you just have player 1, player 2 as properties.
Right.
But what if you have a list of players?
Right. Yeah. So we don't support navigation properties. It's like an ORM thing, right? So ideally, you would have basically the idea of a join. You'd be able to join on something. You can do that currently. You can drop down to sort of raw SQL, and if you want that second table to be queryable and you want it to actually be a table, you can drop to raw SQL and write a join and bring up the appropriate players. So in your actual table, you'd store like a list of them, a list of their IDs from a different table, and you write a join, pull them in. That's if you actually want them to be in a separate table and you want them to be indexable. If you don't care, there's actually a really neat trick, which is you just take the JSON blob that came on the wire and you stick it inside the property as a text string. If you never need to search through those players or list them separately, that's a nice trick you can do.
In Josh Twist's talk from Build, he alluded to that trick, but he didn't actually talk about it.
Okay.
So is that trick documented somewhere?
It's not in the official docs because we hope one day to actually do proper joins. but I can point you to the blog post or yeah. Just follow up. We have it somewhere. Question back there. Concurrency? So our server scripts basically, you have to understand a little bit of how Node works. So Node has an event loop that's single-threaded. So there's basically a queue of HTTP requests that pile in, and they get pulled in one at a time and executed. So basically, you only have one request running at a time in your server script. So you don't have to worry about locking or anything like that. The Node event loop takes care of that for you.
So I guess another question here. So when you said only one script is running, I guess many instances of your one script may be running in parallel. It's just that each one is running as a single program thread, whatever you want to call it. Is that right?
There's only one thing on the thread at any given time.
Well, that I understand. Let's say 500 requests come in at the same time.
Yeah.
And server has the capacity, so it starts 500 instances of your script. They don't share any data or whatever.
It's not going to start 500 instances of script. It's going to start. Is it start out?
They're not sharing any code between. They're not sharing any memory between them.
No.
Okay, so I guess there's no concern.
It's going to start one instance of the script, but it's going to queue up 500 of these callbacks. But you can. There's no like static variables or anything.
So that's what I got. You said the 499 will be queued up behind the one. Is that
Yeah,
right?
yeah, and they'll be picked up one at a time.
So let me ask you about the way you guys have implemented it. So you have a bunch of servers, right? Is your script running on one server only?
Yeah. Yeah.
It's not being like multiple requests come in, they're not being divided to multiple.
No. You're always on the same machine. Yeah. You're always on the same machine. You're always in the same process, actually.
Okay.
You have to. So your next question is going to be, well, like I'm gonna peg that thread, and then my app is going to stop responding, right? That's kind of your next question.
Actually, not really. I thought since this is running in a pool, shared pool, I thought the request will come and get redirected to individual servers, and if they have capacity, they run your script on all of them one by one.
That's not how. Yeah, you have one instance of the app running by default. Now, if you configure multiple instances yourself, like if you go to the configure tab in the portal, you can go ahead and say how many instances would you like to run, and then in that case, it will get load balanced to one of the instances.
Okay, so by default, there is no load balancing on one.
But yeah, by default, no. But if you go here to this configure tab, or is it the scale tab? Sorry, or the scale tab. You can go ahead and switch to reserved mode, and then you can start dragging this slider and adding instances. Yeah. Any more questions? Over there?
Can we do authorization?
Yeah. The question is, how do you do authorization? We don't have a nice declarative way like maybe you're used to in the framework where you can put some attribute on the method. Basically, whenever you have any script here coming in, so let's say inside of our games table, inside all operations, you'll get this user object passed to you, and then you can do validation based on the user ID, or authorization based on the user ID, but you have to write imperative code to do that yourself. We don't have anything like roles or anything like that.
For instance,
sorry,
can we do sharing in the same way? Like a user created let's say a blog. But you want to share with another user. Can we do the code there that says it's this user or?
Yeah, by default, all users can access everything that's being created, unless you manually put a check to block someone. You have to manually build the authorization mechanism you want. Like I think you'd have maybe like a list of users and their permission level or something like that, and then add them to some kind of group and then check for the group. But it's a manual deal at this point. We are thinking of doing a users feature. A first-class users feature, which would have authorization built in. A question back there?
Yeah, I read online somewhere that you can use mobile service and cloud service together. And can you just briefly describe how?
The question is how to use a mobile service and a cloud service together. So basically, the same way your client talks to your mobile service, it uses a JWT, a JSON Web Token. So that's basically something that gets generated. The token gets generated by the server, and the client sends it over every time. Like they both generate that token using that master key, or that application key. Sorry. So if you're able to extract that token, and we don't provide you an out-of-the-box way, but there's plenty of blog posts and workarounds. If you're able to extract that token and use it as part of your .NET app to send requests, then you can do it that way. Basically, figure out a way to generate the token or steal the token, and use that to authenticate and talk to the backend.
So if your secret gets compromised, is it possible to convert your tokens from one key to another?
Yeah, so we give you, I think, 2 at any given time. And you can go ahead and regenerate any of them independently.
So all your, well, not just this, will my users get migrated to the new key? Because, I mean, once I check...
No, they won't. They will not, no.
Is it possible to write a script to do that?
No. But that's the thing, like, so
like hashing, so you can't really do us.
Well, no. So actually, we always get questions about the application key, right? So the application key, it's really not a security measure. It's because it's very easy to open any Zap and Reflector and get the application key out.
You also have master key, right?
Yeah, the master key is something you shouldn't ever give to users.
Let's say for whatever reason it gets compromised, and I'm using, like, whatever logic I'm using, and I have some custom auth. So now I have those user credentials encrypted and stored on my mobile service, right?
Yeah.
And I want to not have to inconvenience all those users. Like, can I just redo the whole...
Are you doing encryption yourself in this case?
I have...
Off of that master key? Sounds like an advanced question.
Okay. No, but
we should take it offline. But if you regenerate the master key, the service we turn off the old key within seconds. So
isn't your master key being used?
I have to go read through Josh's thing, but you shouldn't ever have the master key in a client application.
Right. So I mean, servers can compromise.
So I won't leave time for Jeff, so I can take any questions after. All right, great. Thank you, guys.
My name is Jeff Wilcox, and I am kind of the most successful failure on the Windows Phone. So my application has netted me no money and cost about $15,000. But the good news is I'm sharing my experiences there with everyone. So you win some and you lose some. In the past, I was on the Silverlight team. I worked on Windows Phone 7 and 7.5. And these days, you'll find me in Windows Azure. I run the open source dev team on like the SDKs. And I work with Javor's team quite a bit. That said, I didn't build my application, Fourth and Mayor, with any of these cool things because I built it 2 years ago. And about 2 years ago next week, actually. So this is my list of laundry topics to go over. And we'll see what time we have for going through this. Feel free to interrupt me at some point, but hopefully I can get through some of it. I'll probably go for about 20 minutes here. So first of all, what the heck is my cloud environment? When I launched my app for the first 6 months, I actually did not have a cloud store at all. And so my application, it's actually based on the Foursquare API. And so if you want to check into a bar or you check into work, to do that, you actually use the Foursquare API. And that's not an API I run. Foursquare runs it. And so my application just went direct with OAuth against their service. So super easy for me because it didn't cost me any money. Foursquare allows me to do this for free. And it was easy to code up. The trouble is I can't add value on top of that. And so if you look at things like live tiles, toast notifications, doing work for my users, I can't do any of that since my app just went direct to their service. And so eventually I started building up this crazy set of independent components. And to be clear, this is kind of me as my non-Microsoft self. So as employers, Microsoft's nice enough to let us moonlight, do some stuff on the side, and hopefully we're being kosher there. That said, at the time, I was looking at Amazon Web Services. Gosh, the price was right. It was like 30% cheaper. And since I wasn't going to charge for my app, this mattered to me. And it was a good time to learn about some competitors' products. So V1 was built completely on Amazon. And that sounds great, but it turns out when you work in Windows Azure, you should maybe just be able to answer to your CVP, how would you run your service on Azure? And so I'm actually in the middle right now of kind of moving my entire app over to Azure, just to prove I can. I have a couple actually unique reasons economically that Amazon is cheaper for my very specific app, but everything runs in Azure, great for the most part. And apologies, if you're a phone developer, you probably don't care about most any of these things, but someday maybe you will. So on the Amazon side, I use them for all my DNS hosting, and that's because today Windows Azure doesn't have kind of custom arbitrary DNS hosting. And so even when I move over to Windows Azure, I'll still be using that product. But the other classics on Amazon's side, EC2 is their Linux virtual machines, load balancing storage, text notifications, All of these things are great. That's kind of what the app was built on. And so the infrastructure was a couple EC2 instances, mostly small or micro instances, that were running Node.js, running web servers, doing push notifications, all these fun things. And then one unique service I use in Amazon is I'm talking to Foursquare, because my application is a Foursquare application. And it happens that Foursquare is located in the US East Amazon data center, the same data center as my app in Amazon. And so I can talk to Foursquare for $0. I can download terabytes of data. I can send them terabytes of data for $0. That's actually a pretty big driver for one of the reasons that I'm running in Amazon today, because Foursquare is not in the Azure data center. So in my case, it's kind of a unique reason where today my production service is still in Amazon, and that probably won't change in the short term, but I'm finding ways to move it all over and piece in things. And so I'm actually running some of my web service API servers and my website now off of Windows Azure. And the nice thing with DNS is you can move providers. You can even do round robin. I could have my website some days be hosted by Amazon, some days by Azure, and kind of smoothly work that through until I fix all my bugs. On the Mongo side, I'm using Mongo's NoSQL database solution, and it's mostly because I'm written in JavaScript. JavaScript is super sexy right now, and Mongo gives you JavaScript JSON back. And so it's really simple. In the Amazon data center, I pay Mongolab. It's a third-party company that hosts Mongo. I don't want to worry about administrating the server. I don't want to worry about instances. I pay them $40 a month, and in return, I get a pretty large amount of data, just completely hosted, backed up. It just works. No worries. Now, on the Windows Azure side, in the Windows Azure store, we actually also have Mongolab, the same exact company, the same servers, the same smart guys. They're actually hosted in Windows Azure as well. And the cool thing here is that they're actually not charging right now because they want to get test users. And so in Azure, this cost me $0. So it's kind of an interesting thing where each provider has its own pros and cons. And one pro in Azure right now is it's free in this specific case. On the big list on the right, Windows Azure. Websites is the big feature that was launched last June. And
we might try to share the slides possible. It's not shared in the sharing
link.
Just for a sec, guys.
Sorry, we're rocking link here. Share the desktop. Sounds good. Okay, is that better? Okay, great. So on the Windows Azure side, Windows Azure Websites is a super simple way to host your website. So on Amazon, I have to actually spin up entire EC2 instances. I have to install the web server. I actually go through the crazy steps of building Node.js from source and crazy stuff. I can automate it, but it takes a while to kind of launch things. And with Azure Websites, I literally just git deploy my code, and like 20 seconds later, all of my instances are running the latest version. And so I'm actually running both a production instance and then staging instances in my backend there through Azure Websites, and it's super cheap. I run a whole bunch of different services, and they're all independent. And so the idea is that if my live tile generator goes down, well, that kind of sucks, but turns out the rest of the app's going to work just fine. And so I've kind of done a little bit of hedging here on my environments. And so I'll actually watch the load, over month to month, just see how the load's doing. And the live tile server is pretty much the most expensive part. It's a lot of CPU to generate PNG images, but it's actually the best part of the app is, live tiles are kind of a great Windows Phone value add. And my code actually also generates Windows 8 live tiles, although I haven't released that app yet. Other things that go on, I'm actually using the classic cloud services. It's kind of the traditional way in Windows Azure that you push code. And this is the thing that sometimes takes like 10, 15 minutes to spin up an instance. And it's doing a full Windows VM. It's extremely fault tolerant. And so I'm doing this for email processing. If you send me a crash report, my code actually will parse your email, figure out what the bug is. And today I get that information. But one thing that I'm looking at for the future is actually emailing you back and saying, thank you so much for your bug report. Here's the ID of the issue. It's already been logged. Or 10,000 other people have sadly had the same issue today. Kind of some value add on the side of crash reporting. I'm doing that there. And then Azure Websites today doesn't actually support having a custom SSL certificate. And so I have a wildcard cert for anything.fourthandmayor.com. And Websites doesn't support this today, but according to Scott Gu's blog, someday it will. And so until that time, I'm actually running my own SSL load balancer in Azure. And so it's a bunch of instances that have my certificates. So I get the incoming requests. I will actually re-encrypt on the back end with Azure websites, do the magical things, and then push it back out. This is actually, it's like 20 lines of code in some web config file. It's pretty easy to set up, actually. But it's important because I'm looking at customer data. I'm getting information on GPS locations. I don't want this stuff just freeform on the internet. So I try to respect my users a little bit. I'm also using the Azure Table Store. And so I have a logger built into my Node app. It's kind of like the equivalent of console.log. It would really be painful. Like, honestly, I have over 200,000 downloads of the app and about 100,000 active users. And I cannot look at logs. There's no way I do that because I have a day job, it turns out, and a girlfriend and other things that don't really compete very well with looking at log files. But if I need to, I can kind of pull up the log for a specific user, and I store all that in Azure Table Store. It's awesome because Table Store costs the same amount as Azure Blob Store, so it's super cheap, but I can actually query that data. And so I actually partition it by a whole bunch of crazy values, but the magical thing is it's quick, I can query it quickly, and it's just kind of works. I'm also using virtual machines for some statistics stuff, and then of course the Azure Store for Mongo. The fun thing is, how much does this cost to run 100,000 plus users? This is kind of like the fuzzy math on it. Again, Mongo's $40 a month. Amazon used to be about $150 a month, but as I move more services to Azure, I'm actually, my last bill was about $27. And so I'm finally seeing some reduction there as I kind of move my spend for the cloud over to Azure. And on Azure, there's all sorts of free trials and things. I think one of my accounts is currently on the 3-month free trial. So I get 750 free compute hours, and there's crazy things that happen on that. I honestly haven't been able to estimate my spend because it keeps going down somehow. But I'm paying for all these things, and so for me, I'm kind of watching my costs. And so that's a great reason to actually instrument my app and figure out what the heck is actually going on. And I'm actually trying to be redundant, too. You know, you don't want 100,000 really bad reviews of your app on the App Store. And right now, I have tons of great reviews. The average score is about 4.5 stars. I'd like to keep it that way. And so I need to run redundant services. I need to run reserved instances. I need to kind of do the right thing from redundancy, but I'm just one guy, you know. So thankfully, the cloud lets this happen. Before I actually started using the cloud, I was using dedicated servers. And when they went down, you know, you'd have 2 days downtime while they try to figure out how to get things running. So the world is better. Here is kind of a look at some recent bills. So on the top, I couldn't find the breakout for the Azure one, but you can see recently I paid $46 there on one of the accounts. Amazon kind of breaks down your compute hours. You know, I've got 300 hours of a couple instances here from whatever this bill is. I guess this is the current month right now. But you can see that, you know, it's real costs. I'm using real services. And I honestly can't figure out day to day what's happening, but I can do, you know, some estimations to at least figure out what my spend will be. When you're running cloud bills, you know, I think you often think, hey, it's only costing me $2 this month to run my service, but, you know, it could easily be the next, you know, I won't say Instagram, because that would be awesome, but, you know, your app could really kind of take off, and when that happens, at least with the cloud, you can scale some, but cost is going to matter, and so I don't have any silver bullets there to share with you, but here's a look at the Azure Portal. This is the 4th of Mayor set for my subscription here. And so this resolution makes it painful, but you know, there's a bunch of websites. I'm running both the standard websites and then the staging website. And it's 100% identical code in these cases. It's just different branches on GitHub where the code's hosted. And so when I push an update into my GitHub staging branch, within a few seconds, Windows Azure actually pulls that update and it goes live. And then in my app, when I have my debug configuration set up, it uses staging. And when I hit release, then it hits production. And so that's a good way for me to kind of know that I'm testing against a current version. And when I get my app looking pretty good, I'll go ahead and flip things over to release in Visual Studio. And then I'll hit production for a while until I'm really happy, of course. And then, you know, I'll get my bits ready for the marketplace. Other services in here, you can just see as cloud services. There's some storage accounts, pretty typical view. This looks way cooler than Amazon's portal. So Azure's doing some good work. On the right, you can kind of see an example. You can see some graphs of how the load's going over time. And so it's really nice to pull up a week worth and kind of see what the data looks like. Now, these are things that today, at least, Windows Azure Mobile Services doesn't support, or at least not all of them. Clearly, the most important thing I do is push notifications. And so that is sending toasts to users. So if I check in here at Building 99, my friend should get a toast on their phone saying, Jeff just checked in at building 99. That's an extremely expensive service for me to provide because I actually have to do a little bit of computing in the back end. I know where if I know where your phone knows you were, and or where your friends were earlier, and I can look for changes and differences, but that's all cloud computing time. So clearly it's something you don't want to do on your phone device. It would just waste the battery on the phone, but also it's not a cheap service to provide. Crash reporting, live tiles. Live tiles, again, are super expensive, but super expensive compared to parsing an email at least. And then the magic is this continuous processing queue that I have. And so I have some Node code. It is JavaScript, but it is quick. I can process about 50,000 people in 30 seconds. And it'll go through, it'll churn through, it'll talk to Foursquare, it'll look at the database tables in Mongo. It'll figure out what the heck changed. And it's actually some impressive code. And this is all open source on my GitHub account. I doubt the open source would help you because you're not running my app. But if you want to look what these things look like, you'll see the disgusting code that it becomes at times. Since I don't have time to do the code right always, there's a lot of code where it's temporary bug fixes and lots of to-do statements, like all good code. So this is kind of the magic, though. It's really simple. Like the primary queue is maybe 20 lines of code. It kind of pulls a little bit of work off of the Mongo queue. It says, who haven't I seen, who haven't I processed in the last 2 minutes? And it's going to pull that data off and temporarily kind of reserve it. And then I know that even if this machine goes down or something happens, I'll at least see that person again in 2 minutes. So I don't worry too much about downtime there. But the good thing is if I scale, I can scale out from what I have right now is 3 reserved instances. But if I want to scale out to 30, if I get popular, I know that each machine will pull the 20 or so people for that work. And I don't have to worry about other machines pulling work and competing for duplications and all these fun things. But this code is super easy in Node and in JavaScript because one machine is just doing one little piece of work at a time. And so it's actually pretty fun. There's some storage hosted services, and these are really important things that I don't want my web server to ever have to worry about, really. And so when the app notices that it's been upgraded from version 3 to 3.1, there's actually a file that I store in storage that I can pretty much guarantee is going to be up more often than my website is. And so the app actually goes directly to storage looking for that version information, and it'll pop this information it finds. And in my case, I actually store it on a CDN. And so I'll have, what's new in this version. I fixed some bugs. I added an Easter egg or something. I can put these things in the what's new content. I upload it into the storage blob, and then the app just hits the CDN. And so it's really fast for users, but also there's zero, worry on my side. I could spin down all these services on the left side, and people still get information about what's new, the basic live tiles in the app that aren't customized, all these nice things. Then on the other side, there's some other services I use. This is mostly for interacting with users, whether it's running a blog or letting people report bugs. Everyone kind of has their own toolbox, and this is the toolbox I use for my app. I've already mentioned staging, so don't want to drone on too much about this, but I will say that one of the nice things I do is that I literally have all of my keys and certificates. They're different for staging, dev, and production. And they're just literally a JSON file that I don't check into my source control. I actually push it separately. But it's kind of a standard practice. Yavor did it in his app as well. And so that's nice because I can easily roll these things just by changing the file, and I don't have to worry too much. In terms of production challenges I've had, the biggest one is that I am sometimes a sloppy coder. And I don't want to regress my users, especially if I have sometimes 20,000 some people using older versions of my app. And so I'm actually doing versioned endpoints. And so if I go to my API URL, I'll have /v2.1 /v2.2. So each new client app I build, I'll actually, for the most part, clone or in my application expose the same endpoint if I don't change anything. And if I do change things, I'll do kind of like Quirks mode checks. And in the first version of my app, I didn't do that, and I found that it's really painful because people don't always know to upgrade your app. So that's one challenge I've had there. Other stuff, obviously, moving from Azure between Azure and Amazon is a challenge. It's a fun challenge. It turns out vendor lock-in is not real, but it's definitely work at some point. And it's actually really helped me, I think more about the cloud. Is that as much as we like to think that all of the cloud is a commodity. There's definitely a lot of work involved in making an app that runs everywhere. The last two challenges, things happen. Cloud providers go down. Nobody says it's 100% guarantee. There's a guarantee that's under that number. And so what I found is that in my app, one thing I do is I always go directly to Foursquare when I can. And if I need to share that data with my cloud service, once the Foursquare request comes back, then I do my processing with my cloud. And so that way, the core essential part of my app, which is completely separate from my services, will still work even if I do something and my cloud goes down. That's really the best way for me to mitigate it. Of course, if your app is using just your one single first-party service, you're going to have issues there. And you'll have downtime, and so that's going to be about what you show your users. I actually have some code here I'd like to pull up on that. And that's way too big. So a few different things for how I do error processing in my app. The first thing I use is a thing called JSON-P, and it's kind of a specialized version of JSON that lets, it actually wraps the entire request in an HTTP 200 response. And so it'll actually say everything's great, everything worked, and then you'll notice that there's this request parameter. It'll have this information about the request that actually says the real HTTP status code. And this was actually a workaround from Windows Phone 7, back when we kind of had Silverlight style HTTP status codes, and things came back as 404 even when they weren't really 404. And so this is a hack that's been in there for years now. It just proves that code never gets updated a little bit. But what I actually do is I can parse both the HTTP status information as well as special things that Foursquare provides for me. And this is the real code right now for the production app. And I apologize because there's things commented out and I'm trying to localize. But what you can see here is that I kind of have a different exception handling in my app depending on the severity. And so user intended exception is something that at the root of my app, I definitely want the user to see. And so clearly, I want to tell them here their credentials are invalid. There's really no smart way for me to handle this except let the user know it's invalid. They probably need to install again. And along with this, I'll actually sign them out of the application. But that's one kind of thing where clearly I can't do much. Now, this parameter error is a bug on my side. If it happens, it's nothing my user did. It's either a bug on the server side or it's a bug in my client code. And so I'm going to throw the standard invalid operation exception. That's something that I'll get notified about, either in my crash reports through the marketplace or crash reports built into the app. But I found that kind of differentiating a few of these is good. Here's one that Foursquare sends saying that someone's used the app a whole lot in the last hour because you've exceeded the rate limit. And so again, that's something that's intended for the user. Pretty standard there. The other one I have is I kind of do the same stuff right here. Here's a note from probably a few years ago. Before ingestion, figure out this error handling. I don't know how many of you have applications out there in the marketplace or have code that looks like this, but this made it through ingestion, so I guess it works more often than not. But here I kind of do things. I've got some nice notes. So someday this should probably sign out and inform the user to do something different. Today I just break. You can see here that I've got all the notes. I know exactly how I want to do error handling, but I'm a lazy coder. So apologies. In your app, though, you should totally do cool things with these status codes and inform users the right thing to do. This also proves that your app might be a horrible code base, but find popularity. So go figure. This stuff's not too exciting, but again, I'm just literally using an environment variable to kind of switch between what mode my app thinks it is, and it makes it really easy to test on my machine, on another machine, or in the cloud. But here's the good stuff for how you hook your app up, and the nicest thing is actually the first one is the HTTP client library. This is something that the CLR BCL team shipped maybe 2 or 3 weeks ago, and HTTP client itself, it's kind of the basis for using HTTP in .NET 4.5, so like in a Windows Store app, that's what you use. And it actually hasn't been available for Windows Phone until recently, but there's a portable class library and NuGet. Definitely use it. It's got async, await, all the cool methods you'd expect to use. Windows Phone also supports the classic web client and HTTP web request that is really painful to code once you've used web client. So definitely use that. In my case, I have 3 versions of my app. I have the current version. I have a complete rewrite that I'm doing that compiles for Windows Phone 7, 5, 8, and Windows 8. And I'm not done with it yet because it turns out that's difficult to do, but it's building and it works. And then I kind of have a future version where I incubate new features and special features. And in the two later versions, that's where I'm actually using HTTP client. And the code is so pretty now. It's the way that things are supposed to be. You should always think about retry policies when you're doing kind of phone apps. Some people will actually talk that what you want to do is go ahead and always do like 2 or 3 back-off requests if you have a failure. I don't do that in my app because, as you've seen, I don't really even handle errors properly. But the best apps out there do that. I have a friend who worked on the Twitter app recently, the brand new one, and they did a lot of work on retry policies to make sure that the right things happen there. Another thing that today HTTP client doesn't support is actually Gzip Compression. And it turns out this is huge. When I finally added Gzip to my app, there's a couple NuGet libraries out there that do it. I literally saw just crazy improvements in download speed, because if I'm downloading a huge payload of Foursquare people, I'm looking at probably 150K of data, and in Gzip that's often down to about 15K, and so it just kind of flies down the wire. And so Gzip is definitely something you should look at using. Unfortunately, it's not built into the framework today, but it's not even built into like Android by default. You have to enable it typically. So definitely enable it in your apps if you're doing lots of downloading on the wire. In terms of the technologies, REST is a framework that makes it very easy to hook into the cloud. And I have some code here that kind of demonstrates that. So right here is a user request. And this is where I'm trying to get information about a user. And so using REST I literally say, I want to make a new REST request. The resource is to the user / whatever their ID endpoint is. And this is a GET request. Here I'm getting some information about what their ID is that I need to pop in there. And then you just kind of call methods for adding segments, resource names. It's all API driven. And so it's a lot nicer than, you'll see applications where you have lots of string math and string concatenation. This is on the client, yes. This is the Windows Phone, the legacy version that I haven't had time to touch. So here is the wrong way to do it. And this is my push notifications connection in the live application. So it works for 100,000 people, but very poorly. And so what you can see here is that I have some goo to kind of get some URIs, but the URI that I want to send to, I'm doing complete string formatting for. And this is dirty. This is what happens when you don't use REST #. It's just kind of, it's error prone, it's ugly, it's tough to maintain. But the information I send might be interesting. So I send a ton of data when I connect to the client through HTTPS. I'm sending their push URI. That's the most important part. I'm sending their OAuth token so that I can do work on their behalf on the server. I'm getting information about their user ID, the version of Windows Phone that they're using, the version of my application, how many times they've checked in with my app, how many times they've used the app, who the manufacturer and the OS version are for the phone. So this is the awesome data I need to actually debug for users. If you're using Azure Mobile Services, some of this is available, and you can plug it into your app yourself. But this is what I found useful. I don't find it useful to have like unique identifiers or anything like that. It turns out this is pretty much all I need. But it's a ton of stuff. And on the server side, unfortunately, I don't, maybe I can, there we go. On the server side, this here is Node.js code, and this is kind of the inverse of this call. And so it's really basic. I'm hooking up to this connection URL. It comes in this way. I just literally pull all the values out, and then I'm going to go ahead and I actually do some verification and whatnot, and then I will actually shove it into my Mongo database. And this is the data I use for every user, so it's pretty straightforward. Of course, think about caching. My app starts up really quick because I cache this data. I don't really have time to go into too much of that, but I'll answer questions if folks like. Logging statistics. Logging's impossible is my message on the left. You can do it. You should do logging. It's helpful for debugging, but realistically, once your service is in production, you may not even need to do too much logging. Instead, you want to think about statistics. And so I have a server that's called StatsD, Graphite. There's some technologies built there. It's running on Node and Python and some other tech. And I'm running all this on a Linux VM in Azure. And StatsD is awesome because it listens on a UDP socket. And so from my server, I'll send these UDP sockets that are fire and forget. They're super lightweight. They'll say things like, hey, I have a login, or I just had an exception, or some other error. And the beauty of statsd is that if it never gets recorded, statistically you can hope that you still have that data, but your app is not affected in any way, shape, or form. And so I actually use this data whenever I push up updates, or if I switch temporarily from from Amazon to Azure, I can actually see what my bug and error counts change in real time using statsd. And so that's actually the best way for me to do testing is I'll actually switch from Amazon Web Services to Azure for like 5 minutes, see what changes in my bug count, and then I'll flip back to Amazon. And so it's kind of funny. People have no idea that they're changing hosting providers on my side, but it's the same source on both sides for the most part. So it's pretty cool.
And why didn't you use a service like Flurry or somebody?
There's plenty of services that want like $30 a month for it, and I'd rather not spend that $30 a month if the Azure VM's like 3 to 5 right now.
Flurry's free for your first like 5 million hits or something. I mean, you probably exceed that, but most people don't.
Yeah. I guess I just use what I use today. I have a bunch of migration challenges that I'll jump through, but pretty much out of time. So, do you have a question?
I just missed the part where you were showing the URL, the constructed URL with all the different parameters you were picking.
Yep.
What are you using instead of that right now? Are you still using that?
I'm still using this. However, yes, I'm saying this is a horrible way. You should not do this. And this is in production right now. So, yeah. So I think the REST Sharp library is the ideal way to do it. REST Sharp. And so with REST Sharp, it would look more like this, where it would have a single definition of what it looks like. And then I would replace these segments saying like user version, comma, the value I have. And it's just cleaner code. It's probably slower code as well, but it's just going to hopefully maintain changes over the years instead of having to dig my way through these strings. So REST Sharp is really beautiful. I'd definitely recommend trying to use that. And in my new version, I definitely am doing that. Or you can use your own, yeah. Yeah, definitely. Yeah, just don't, strings are dirty. When it comes to scaling, this one, my biggest comment here is that I actually treat every user a little bit differently. And so if you use my app every single day, I basically give you the highest priority. I will do push notification work for you basically every minute. I will do all the work I can. I'll give you the best live tiles. If you use my app once every 2 days, I'll do just about the same amount of work. I will do work for you maybe every 2 minutes. Not every minute, every 2 minutes. But that really scales back my traffic and my costs. If you use my app once a week, I don't really care as much about you, I'll be honest, because you should be using it more often. And so I will do work for you every 15 minutes. And so I have a back-off algorithm based on how often you use my application. And so if you I kind of just assume that people that use my app, they're going to use it often, and in return, I'll give them really good response times on their push notifications and updates. But it's actually expensive for me to do this work all the time. And so by tracking how often people use the app, just based on when they connect push notifications, I can use that to scale back my costs. And I've had people on the web, when I blogged about this, say that it's the worst thing ever. I shouldn't treat users that way. It turns out, you need to make a call at some point on what you're doing. And for me, this really, really saved me quite a bit of cost. And then just side note, if you're doing Node.js development, .NET's beautiful, but on the Node side, it's really quick and it's fun. It's JavaScript. And I wrote the push notification module for Windows Phone for Node. It's just a module called MPNS. And it's actually what also powers the Azure Mobile Services. And then one of my developers created the one for Windows 8. And unfortunately, there's some differences between the frameworks. It's why it's not the same library. But they're both open source. You can check it out. And these are those URLs. My final little plug here is open source and Azure is awesome. Check out this website that we have up at GitHub. You can actually look at and fork and open issues and learn about the team. And you'll actually find the source then for things like the MPNS and Windows notification servers as well. So questions? Yeah?
How have you found that your cost scales along with your users?
So the question is, how have I found that my costs have scaled with users? For me, it's definitely, I see the users come in, but it's not like an exponential growth. For me, I actually have a very, if I look at my download count, it's almost really just a static line. So there's growth that's pretty much well-defined. And whenever I get featured in the Windows Phone Marketplace, I'll see probably a 1,000-fold increase for that day. And so I actually appreciate when people send me tweets saying, hey, your app is featured in the US Marketplace. I'll actually go and I'll actually add, I'll scale up in Azure. I'll add 1 or 2 more instances just to make sure that it's quick. That might not actually be necessary, but I definitely see the spikes. And then long term, it's really live tiles where my cost is. And so for that, I don't have a good solution. Literally, it's costing me more for more users on that feature. And so I think things about pulling back how often I update tiles is really what will save me money there. So again, I think favoring the most popular users might be the best thing there. But that's where my cost truly is.
Or you could charge for a premium.
Or I could charge a premium. Yeah, I've looked into that too. Maybe someday. Yeah.
How about from the inception, when you first published this and there were no users, as you gained users, what did you see your costs? How did it grow?
Yeah, so when it comes to costs, the question is really, over time, how has my change, how's the change in my bill been really? And for me, it's almost been flat since the start, because I kind of went big from the start, and I already had about 50,000 users when I went to the cloud. Before that, I didn't actually have my own cloud service. And I decided to build it kind of to be somewhat redundant and somewhat efficient from the start. And so I'd be running 4 VMs in Amazon when I probably could have been running 1. And so for me, I had more capacity than I needed, but it also let me get a ton of bugs out of my code when it came to consistency in the code. So, yeah. Any other questions, or we can end it right there? Well, all right.
Well, I have a question. There are actually one key thing that I'm almost seeing, which is, this may be the wrong way to do it. I was an engineer, so when I look at code, we're like, okay, there's a hard-coded string or whatever my heart screams, so that's not how it should be.
Yep.
But it almost feels like it's better to build stuff that works and worry about engineering later.
Yeah, so
looking at your sample, I mean, of course you're saying do as I say instead of do as I do. But,
So the question is, Jeff, why is your code bad? And
that's not the question.
That's the way I'm reading it.
The question is basically, would it be right to surmise that don't worry about the code quality, just go ahead and build it, and as long as it works, you can fix it later?
I think everyone has a different situation. In mine, I wish that I had written some of my code better. And so if I look at my JSON objects, I was hand parsing JSON in my first version, and there's still parts of my app where I still hand parse JSON. There's no reason to do that. And so that's just a silly mistake. I was just hacking code real quick late at night. I shipped it, and I have some weird bugs as a result. And so it's a bane of my existence now, is fixing bugs that were from sloppy code. If I would have maybe spent an extra 20%, maybe I'd sleep better now. I think it's a call you need to make yourself. But I think today there's a lot better tools than there were 2 years ago for Windows Phone developers. So there's a profiler built into Visual Studio now. There's a ton of good features there. And so I think Windows Phone development in this era is much cleaner, much nicer. There's NuGet modules. When I started my app, I didn't have those niceties. So, write some bad code, because bad code feels good to fix, but not all bad code. Yeah.
So you told you are creating a new service for each and every app that you are releasing, saying version 2.1, 2.2.
Yep.
So are you planning to take them down, or will they be always going on?
So actually, in my current, the question is basically for versioning on the server, how do you maintain that? So I'm not actually forking the code, because I don't want to copy my code for no reason. Today I actually expose pretty much all the endpoints through the same node module. And so it's literally just one line of code that says like app.connect, comma, v1.1, comma, the module. And so right now it's like no cost for me to do that. It's very simple. And then I have had one version where I had a slightly different implementation. And so I kind of do have 2 different code paths there, but for now I'm not worried about it too much. My app has a kill bit built into it. So at some point I can actually say that version 2.5 is dead, you can't use it anymore. And I store that file in storage. And so the app basically every once in a while will ping that location. And if the file comes back with a specific piece of data, it'll display the message in that file. And so I could say, please update your app, this version's been deprecated. And so that's kind of my solution. At that point, I'd be happy to delete it. I've actually only used the kill bit on a few versions right now. And sadly, all the really old versions of my app don't have a kill bit. And so I still see tests running. I think maybe the Windows Phone team has versions of it in the test harness somewhere, because I still have people using a version that I know for a fact doesn't actually work. But it is what it is.
How do you know whether your app is being active or is it dead? Is there any way that you are going to track it? I mean, for me to know that 2.5 is not used,
Right, so the connection code I had actually sends the actual application version that is in the client package. I send that to the cloud. And so I can actually do a query on my Mongo database to say, what are the versions, give me that list. And so I do look at that. Another thing I do, though, is I actually do prune my list. And so if someone doesn't use the app for a month, I'll prune that data off of the database. And so I don't have long-term stats there, but I know today what the versions are. And it's a little script I ran to do that. And then I also do have analytics that will show me maps of where users connect from and what version they use.
So there's a follow-up question on that. So do you have any sort of random graph saying number of users versus version? Like how long do people not update?
I haven't had the time for that. So the question was, do you have historical trends and data? And I don't have enough. I have the marketplace data, but that's about it. Yeah. Question in the back?
What's the security measures that you need to take on the client level?
Yeah, security measures. That's a tough one. So for me, I'm just going to open these analytics real quick. For me, when it comes to security, I'm doing quite a bit of work when it comes to actually protecting my endpoints. And so, sure, Azure is secure or whatever, but I protect my credential files. And then I also protect, I always validate the data when it comes in. And so on the server side, everything's coming in through SSL, but I'm actually checking every parameter, make sure that it actually conforms. And I'll punt the data that I don't think should go into the data table. So that's a little measure there. When it comes to the client side, people can get your OAuth token, and if they were to steal your phone and be a computer geek, but it turns out your OAuth token can be revoked, and I don't store any other data on the phone that would be an issue there. So that's what I've done. But I also know that if I were to build this app at Microsoft, my manager would have a very different opinion about privacy and security. So you have to kind of make your own call. On my server side, I do have a small amount of user identifiable data. Since my app has to actually know where you were recently, I basically know for any user I could look up this information. And I've kind of tried to abstract that out so my logs don't have the data, but it is actually in that Mongo table. There's really no way around that one without doing a lot of work. Yeah. Question on the left?
Do you protect your endpoints?
How do I protect my endpoints?
Yeah, can anyone just write an app and talk to your endpoints?
Yep, anyone can write an app and talk to mine. But if I can't find your legitimate push URI, which is given by the Windows Phone notification service on the phone, then you're not going to get anything. It'll just punt the request. And there's really, that's like a huge encryption question is, how do you protect your web service endpoints on the client? And the answer is usually you don't. And people will write these Instagram apps that hit Instagram when they're not allowed to. They have ways of identifying it, but in general, it's really hard to protect those things. Yeah. Yep.
Have you done any work around convergence between your Windows Phone and, as you said, you have something in the works for Windows 8?
Yeah, so I do have a version of my application which I build across all these different things. So if I go to my source code, if I drop into the future version of the app, so Windows Phone 8, it's kind of hard to see, but visually there's links here. These are all Visual Studio links. So I shared the same exact source file with every single version of the app, whether it's Windows 8, Windows Phone 8, whatever else. And that's taken work to maintain, but it does build. So that's the convergence story, but it's very slow. So I wouldn't recommend it for everyone. And I haven't shipped the app yet because it's been a big challenge.
Is there a reason you're not using a PCL?
PCLs are great in some situations, but for me, the way I'm structuring my data, portable class libraries don't work for me. But I'm also a little bit over-engineered in some things. Yeah. Okay, well, I don't want to keep you guys too much. I'm happy to answer more questions, but we have an Ask the Experts thing. And this is just to show folks that on the analytics side, it is useful to know where your users are. If I zoom in on Washington State, you'll notice that most users are in the Seattle-Redmond area. There must be a lot of Windows phones here. So anyway, thanks a lot, and I'll be around for questions.